Hello everyone, welcome to Enviro Pioneers. In this video, we will learn about the mechanisms or different processes that are responsible for rising an air parcel up in the atmosphere. In the last video, while understanding the adiabatic lapse rate, we saw that when an air parcel rises up in the atmosphere, it expands and cools, while when it descends down in the atmosphere, it is compressed and gets warm during the process. So the question is why we have the vertical movement of the air parcel. Means how does this air parcel move upside? So in general, the tendency of the air is to resist the vertical movement. But there are several mechanisms that cause the air to rise. And if it reaches above the condensation level, then it triggers the formation of cloud. So these mechanisms they include localized convective lifting, orographic lifting, frontal wedging, and convergence. So let us understand about these mechanisms in detail. So the first is localized convective lifting, in which unequal surface heating causes the localized pockets of air to rise because of their buoyancy. In video related to temperature, we saw that land surface gets more heated in comparison to the water bodies, and on land also different features have different absorption capacity of the solar radiation. So depending upon the heating of the surface, the air just above the surface will get heated. So here it is mentioned that on warm summer days, unequal heating of Earth's surface may cause the pockets of air to be warmed more than the surrounding air. So here we have two examples that air above a plowed field will be more warm in comparison to the air above the adjacent fields of crop. And the second example is mentioned that air above a paved parking lot, which is made up of concrete structure, it will be more warm than the air above the adjacent wooded parking lot. So, as a result, the parcel which is above the field or the paved parking lot, it is much warmer and less dense than the surrounding air. So, it will rise upward. So, these rising parcel of the warmer air are called thermals. Now the question is that why this warm air rises up in the atmosphere. So warm air is less dense than the cold air because heating the air increases the kinetic energy of its molecule, which causes them to move faster and spread farther apart. Thus it expands the volume of the air parcel. And as the density is mass per unit volume, so a larger volume with the same mass of air, it results in the lower density. And opposite to this, the colder air has slower moving molecules that are closer together and they occupy a smaller volume and it results in the higher density. So we have this fundamental that the warm air has the lower density compared to the cooler air, and as the temperature increases the density of the air decreases. But still we have this question that why this air, even if it is having the lower density, how this air parcel is rising in the atmosphere. So according to the parcel theory explained at the website of the National Oceanic and the Atmospheric Administration, it is mentioned that the Newton's first law of motion explains that the velocity of an object will remain constant unless another force is exerted on that object. Means an object at rest stays at rest and an object in motion stays in motion unless acted upon by an outside force. So, according to this law, there must be any force exerted on the air to begin its motion, and decrease of the density alone is not enough to cause the air to rise. So, that force which is causing this vertical movement of the air parcel, that is the gravity. As explained in this image, that this is the air parcel which is warm and less dense in comparison to the surrounding airs. So the gravity it pulls cooler and the denser air towards the earth surface. And as this denser air reaches the earth surface, it spreads out and it undercuts the less dense air, which in turn forces the less dense air or this warm parcel of air up and into motion, and it causes the rise of this air parcel. You can visit this site for more explanation on this parcel theory. If the rising parcel contains moisture, it is even more lighter in comparison to the dry air parcel. So here it is explained that why the humid air is lighter than the dry air. If we assume that the boundary of this rectangle is representing an air parcel, and within this volume we are having the components like the oxygen, carbon dioxide and the nitrogen. And here we have the molecular weight. Oxygen molecular weight is 32, carbon dioxide is 44, nitrogen is 28. So when we are talking about the humid air or the moist air, some of the molecules of the dry air are replaced by the water molecules. And if we see the molecular weight of the water molecule, it is only 18. So, in the humid air or the moist air, the molecules having the high molecular weight are replaced by the water molecule which is having the less molecular weight. Thus, the humid air or the moist air, it is lighter than the dry air. Now, coming back to the thermals. So, thermals are the updrafts of the warm air that rise from the ground into the sky. In simple word, the warmer air which is rising above in the atmosphere, that is referred as a thermal. These thermals are used by the birds such as hawks and the eagles to carry them to the great heights, and they do so by flying in a spiral circular path within these columns of the rising air. So, by this process, they are able to ride the air current and reach to the higher altitude by expending very little energy in the process. Now we know that these thermals are produced by the unequal heating of the Earth's surface, which causes the pockets of air to be warmed more than the surrounding air. As we can see here, the explanation of the first example, this part of the field, it gets more heated in comparison to the surrounding agricultural field. So, as a result, here we have the formation of the thermals. So, we can see this is the rising thermal, and if this rising thermal reaches the lifting condensation level, cloud formation occurs up in the atmosphere. So, the phenomena that produces the rising thermal, it is called localized convective lifting or convective lifting. And when these warm parcel of air rises above the lifting condensation level, cloud formation occur, which sometimes produce the mid-afternoon rain showers. And the height of the clouds produced by this process is somewhat limited because the buoyancy which is caused by the unequal surface heating, that is confined to the first few kilometers of the atmosphere, and also the accompanying rains which is occasionally heavy, they are of short duration and widely scattered. Another mechanism is the orographic lifting, in which air is forced to rise over a mountainous barrier. So, this orographic lifting occurs when the elevated terrain, such as the mountains, they act as a barrier to the horizontal flow of the air. So, when this horizontal flowing air comes across a barrier, it ascends this mountainous slope. And in this process, adiabatic cooling occurs, and it generates the cloud and the precipitation in the windward side. But after this, when the air reaches the leeward side of the mountain, much of the moisture has been lost. And as this air descends, it gets warm adiabatically, and due to this reason, the condensation and precipitation are less likely in the leeward side. The irregular topography of the mountain, it is also responsible for the differential heating, and it causes some localized convective lifting. So the combined effect of the differential heating plus orographic lifting results in the higher precipitation in the mountainous region in comparison to the surrounding lowlands. And this is the reason that many of the rainiest places in the world, they are located on the windward mountainous slope. Next mechanism is the frontal wedging, in which the warmer, less dense air is forced over the cooler, denser air. And this mainly occur when we have the collision of the air masses having two different temperature. As explained in this image, that we have the warm moist air coming from this direction, while the cool air coming from opposite direction. So when we have the collision of masses of warm and the cold air, it produces a boundary, and this boundary is referred as the front. And as this warm moist air is lighter, this cooler denser air acts as a barrier over which this warmer less dense air rises. So this process is called frontal wedging or frontal lifting. So ये कब होगा? जब when we are having the collision of air masses of two different temperature, जहाँ पे जो cooler air है that acts as a barrier for the warm moist air, and this warm moist air rises along this boundary or front. And as this moist air parcel rises up, it will expand and cooling will occur, and if it reaches the lifting condensation level, cloud formation and precipitation may also occur. So, in the frontal wedging or frontal lifting, the colder, denser air, it acts as a barrier over which the warmer, less dense air rises. As this warm air rises upside, it will cool eventually, and if it reaches above the lifting condensation level, cloud formation may occur, and accordingly precipitation may also happen. And the fourth mechanism is the convergence, where a pileup of horizontal airflow, it results in the upward movement. So it mainly occurs when the wind pattern near the earth surface is such that more air is entering an area than leaving. So, this convergence lifting mainly occurs when the air flows in from more than one direction. As we can see in this image, the air is coming from this direction also and from this direction also. So, here we have the pileup of air mass which is having nearly same temperature, and as this air mass cannot go down, it rises up in the atmosphere. So, in the convergence or convergence lifting, the air converges as it is coming from many directions. It piles up and is forced upward. And this leads to adiabatic cooling and also possibly the cloud formation. Convergence can also occur whenever an obstacle slows or restricts the horizontal airflow. Here we have the example for the same, when air moves from a relatively smooth surface onto an irregular landscape. So, as it comes on the land surface, there is increased friction which reduces its speed, and it results in the pileup of air, which is convergence. Florida Peninsula, this is the excellent example to understand the role of convergence in initiating the cloud development and precipitation. This peninsula, it receives the moist air from both the direction, as we can see here, and due to convergence the piled up air mass, it rises vertically in the atmosphere, and due to rise of these air masses the adiabatic cooling occurs and eventually cloud formation. So this convergence is the major contributor to the weather associated with the middle latitude cyclones and the hurricanes. So in this video, we understood about the four processes or the four mechanisms that are responsible for rising the air up in the atmosphere. First was convective lifting, where the unequal surface heating causes the localized pocket of air to rise because of their buoyancy. Second, we saw was orographic lifting, where air is forced to rise over a mountainous barrier. Third was the frontal wedging, where the warm, less dense air is forced to rise above the cooler, dense air. And the fourth was the convergence, where the pileup of the horizontal air flow, it results in the upward movement. You can refer to the chapter Moisture and Atmospheric Stability in this book, The Atmosphere and Introduction to Meteorology. We will meet soon in the next video related to the temperature inversion. Thank you and best wishes.